And hi, welcome to Kaplan's free week of MCAT. How are you? Hi, it's me, Kaplan's my specialty. How are you? Give me a hi or hello. Let me know how you're feeling today. It is time for light and optics. What we all need. Hi, Jen. Hey. Hey, Giselle. Hi, Sarah. Hey, Anaga. Hi, Vivian. Hey, Annette. Samantha, thank you so much. I really appreciate it. You know what I did today? It's not even like hard. This is what I do actually when I don't want to do my hair. I'm not kidding. Is I have one of those 3-barrel wavers, and I just like put some product, and I just 15 seconds, 15 seconds, 15 seconds, boom, it's done. It's so easy. So it takes like 5 minutes. I appreciate it. Hi. Don't freak out, Euro. What did the Harvard study tell us we're supposed to do whenever we start to feel nervous? I talked about this on yesterday. I know you guys remember. What's not to be upbeat about, Lillian? You know what? I tell you what. I went to undergrad on full scholarship, and I went on after undergrad on full scholarship as well on the back of these tests and whatever. And I still had to sit down with my family and tell them that I wanted to work in test prep for the rest of my life after doing all of that. And they were very surprised. But that's the reason I'm always so upbeat, is because I found my thing. I found the thing that just makes me so happy, and that's helping y'all. So you never had to thank me for being upbeat. I really should thank you, because you guys give me the opportunity to do what I love to do and to live out my dream every day. And I really mean that. Yes, we're going to be excited instead of nervous. And you don't have to get yourself excited, at least. You just say, so excited. Just tell yourself in your mind that you're feeling excited, and your brain will then start to reroute that fight or flight chemical that is saying, run away, into, oh, it's time to fight, or we're going to do a boxing match. I'm here to stay. Because you don't want your brain trying to run away while you're taking a test. That's the worst. So just tell yourself over and over, I'm excited, and there's study shows that it will actually help with performance of the test. So we're going to make sure to be doing that. How are you guys feeling about light and optics? Is this a subject you touched on in your studies? You haven't yet? On a scale of 0 to 10, how much prep have you put into this topic? There you go, Lennis. Lennis knows what I'm talking about. Got 4, 4, 0, 2, 3, 2, 2, 1, 5. All right, so the highest we have is like 5. You're like, yeah, I like done some. Okay, so yours like none. And blames the professor. Darn you, professor. There will be things on the MCAT. I think I've heard that before, that there are definitely things that, depending on what program you went to and how your school set up their curriculum, you may not have had. So that's a thing to know. Whoa, okay, so the highest, oh, Janini's like, listen, I'm going to be an optometrist one day. I've been crushing this. Of course, good. So I'm glad to see that no one is like a super expert. So I think that means that everyone has something to gain here in this lesson. And for those of you who are saying 0, that's okay. I think that this is still a great lesson for you. It's not too advanced and it's not too beginner either. But you know, if you have questions at any point, what do you do? What do you do with your questions here at Kaplan? Or rather, what are we going to do with your questions? Because we want you to ask questions. We want you to ask questions whenever you have them, as soon as you have them, no matter how big, how small, just go ahead and ask it, because you don't want that stuff to compound, because little questions turn into big questions, and eventually you just all turn around in a subject and you're really not sure where it began or how to unravel the confusion. So it's better to start really early. So we're going to ask questions whenever we have them, because what do we do with it? Well, we give you a private tutor. So you have a private tutor standing by. Basically, if you say something that ends in a question mark, it's most likely going to have a private tutor run and start a conversation with you privately right away, because that's what we love to do. We love to answer questions. So we're very excited to do that for you all throughout class. And if you are watching, I got some emails too from some students saying that they weren't able to chat in because they don't have either Facebook or Twitter. So if that is you, feel free to still use the email that is pinned above. Over, I don't know, from where I'm at, it might be over there. Consultateacher@kaplan.com. It'll go to me and to my team. We'll be happy to answer any of the questions that you do have. I'm actually really proud to say that as of 15 minutes ago, we had answered every single question except one. So I was super proud about that. Of course, that one student is probably not super happy. I believe it was you, Emily, but I have your question. I am typing up a response. We're making it look pretty. I want to make sure that I gave you a detailed response, because your question was very content-based and deserved that. So I want to make sure I haven't forgotten you. And for everybody else, you should have received a response if your email came in prior to 7:30. But otherwise, just keep sending them, and we will get back to you on tomorrow. Let's get started with our agenda. Let's start with a welcome and introduction. Hi! Welcome to Kaplan. You have made your way as the world leader in MCAT prep, home with the most live instruction of any MCAT prep course. We're so excited to have you for the free week of MCAT. I just love saying that. I just love being a part and place to give the free week of MCAT, because it's really awesome, and we're happy to have you. I am Kaplan's Plus Coach Allie. That means that I am big on study planning, and a lot of the questions that we've been getting have been about study planning and setting up that timeline. So I love to see that, because sometimes students miss their test dates and or just get overwhelmed or come very near to burnout. And the root source is not intelligence. It's not that you don't have the capability to do well on this test, but it's rather that maybe you're just like meandering through all of the resources in the world, which doesn't necessarily get you points very quickly, or maybe have unrealistic timelines, or not thinking the right amount of hours and all these things. And so I love study group questions, just because study planning can be a huge huge reason why students don't reach their goal in their time frame. And it's something that can easily be fixed. Like, you don't have to learn a whole bunch of science in order to fix that part of your prep, right? So that's something that you can fix, fairly easily with some help and some guidance. I'm very happy to see all those questions coming in. Y'all are obviously embracing the idea that having some amount of structure and thought and being purposeful in what you're studying, what resources you're using, and when and how you're using them, it just really warms my heart. So I'm glad to hear that. We're going to do an overview of the MCAT because we always have people who are new. Shout out today if you are brand new to MCAT today. Who is new? Brand new to MCAT today. I feel like every day, every class, I have at least one. At least one. No, I'm not new. I feel like I've been taking tests forever. Forever. Hey, Kelsey, welcome. Hi. I doubt you're the only one, but you're the first one that I've seen. Oh, there we go. There we go. Hey, Mr. Como. Hey, Cece. I know that name, Cece Parker. That sounds like a name that belongs on a plaque. It's just a very happy name. Hey, Erin. Hi. All right. Hey, Shantarius. Hi, Jarrett. So hi, newbies. So I always like to start with an overview because we want to be able to put the lesson into context. And those of you who've been with me all week will definitely know this because we've been talking about it. I'm not going to belabor too much of it though because we have talked about the overview all week. But if you have questions, let me know. Feel free, and we'll go through them. Okay. Plus coaching will follow. Today's plus coaching topic is one of my favorites. Let me see. I'm going to see if I can give you a. Let me see if I can give you storage, retention of information. The reason that this is one of my favorite plus coaching topics is because it's also something tested on your MCAT. So we have put a little MCAT in your MCAT study planning. So I'm really excited about it because the things that we talk about, I'm going to put the idea of storage and retention into the context of MCAT study prep, which is what you're working on. But all of the takeaways from today's plus coaching lesson are things that are actually tested on the MCAT. So hey, a little extra MCAT with your MCAT. It doesn't get no better than that. So very excited to be doing retention for plus coaching today. Let's get started with our overview. Of course, our scoring, we know that the average score for all the times the test is taken, it's about 500 on the MCAT. But what, very good, Carol, very excited. What is the score that we were shooting for? What is that average score to get into medical school? Bonus points if you know the range. Very good, Deidre. 510. 510 from Kelsey. Yeah, you guys have been coming. Megan, Jamie, all my frequent flyers. Hey, hi, Anissa. A little bit higher, you guys. A little bit higher. Yeah, so we're going to do a 510, right? So the range is 509 to 511 for average admit score. So calling it a 510 is really safe bet. Yes, Byron, you're absolutely right. For your DO programs, it's going to be a little bit lower, looking at 506 to 508. Very good. And then, of course, that 510 number, that is the number for your MD program. Very good. Now, you really have to also look at the way that this test is scored to really judge maybe how long it's going to take you to prep. Sometimes I think maybe because we're so used to the out of 100 score range that something like 5 points, 6 points doesn't sound like that far because, if I'm trying to go from 90 to 95, well, that's not so far, right? I can do that. I can do that in a month. That's not so far. But that is very different from trying to go from 505 to 510 on the MCAT. So if you are using your score, your out of 5.8 score from your baseline diagnostic or your most recent practice test, I don't want you to look and try and eyeball between like, oh, I'm at 502, I'm trying to get to 510 or 514 or whatever it is. I want you to look at the percentile and then apply that to what you know out of the out of 800 score. So if your percentile is an 80 and you want to get to a 90, that gives you a better understanding of kind of maybe how much work that would be, or if you're trying to go from 60 to an 85, that puts it in a better range, I think, because sometimes students will tell me, well, I'm really close. I'm at 493. I'm trying to get to a 502. And I know it can sound close, but that can be really very far in terms of how much prep time it's going to take. And time is of the essence. And just knowing realistically how much time it could take us, how many resources we might need, how many hours we might need to put in. These are all conversations that we have to have with ourselves, and very honestly too. And we have to be able to put in that context. So make sure to take your score, not just the number, but the percentile, and hold that up to the percentile that you're trying to get to. And you can find all of that on the AAC website. Let's talk about science content. I love this pretty picture. Make sure to take a screenshot. Here you can see how they love to put MCAT in your MCAT. The MCAT loves it. They're testing all sorts of things. This is another reason why I always say you should lead your content prep with MCAT prep. Because if you're missing something, or even if you learned all the content in the world, let's say you have the amazing Kaplan 7 series MCAT books, which most of you do. Shout out if you have them. I feel like most of you do, because most of the emails that I got, and also most of the people who care for MCAT ever will get them because they're very good. But I did get a lot of emails, so I know a lot of you do have them. But knowing all of the content in the world is not enough for this test, because you also have to know how to apply that content knowledge in terms of real MCAT prep questions or MCAT style prep questions. It's not going to just be enough to say, oh, I know that content, especially because, and one of the big reasons is right here, the way they love to mix sciences together to ask a question. So that's just something that you have to get practice with. And focusing on this content area, then this content area, then this content area discreetly does not necessarily prepare you for those questions where they cross over on the sciences, which happens all the time. So you make sure that you are leading your content prep with MCAT prep. Also, because you don't want to get too bogged down, feel free if you want to chime in. If you're one of the students who wrote me talking about wanting to know how to fix that gap, because I actually got a lot of emails where we were discussing a gap between, okay, I'm doing practice tests, so I'm able to gauge where I'm at, I'm able to build endurance, and I'm doing a bunch of content review, and I'm doing that afterwards, but there's an in-between that's missing. This is a gap I talked about with a lot of you via email. And you may not have emailed me, but you may have also experienced it. You have that same gap in your prep. It's okay, but you need to make sure that you do fill that gap, because I think that gap is really the most important part. And that's where you target your study on discrete items. So I would kind of switch your focus. If you are one of those students who's focusing mainly on content, I would switch your focus to studying mainly MCAT prep materials and questions, in-format questions, and then using your performance on those questions to really gauge, okay, what content should I be studying? Okay, what content am I missing? And that way you get both at the same time. You get direction with your content study, but you also get the opportunity to apply and practice what you're learning and see what you need to learn next, because I don't want you guys just meandering through resources. And I will tell you what, as great as those Kaplan 7 series books are, I have never seen a student who needed to read every single word of every single chapter. I've never seen a student like that, because you are not missing every single content area on the test. I've seen some students who got pretty close. You know, maybe they were not, maybe they were like English majors and they're switching their whole life plan, but I've never seen a student who needed all of it. So just make sure. One of the things that we do here at Kaplan for our students is we always start with a science content assessment in addition to a fully MCAT diagnostic test. That way we can see where you are just on science content. But when you don't have that ability, then what you can do instead is take some practice MCAT questions, discrete questions, and follow the patterns and see where they're leading you in terms of what content information you're missing. And in that way, you're also getting MCAT practice at the same time. So that's a big fix for probably my most common question we get emails since yesterday. Let's talk about those MCAT science skills. Yesterday, we talked about when was the first time, or what was a big giveaway for us, that the MCAT was not just a traditional science test. I really do think that understanding that this is more than a science test is kind of the key to the whole thing, because it changes the way you prepare for it. It changes the way you think about it. And it also changes the way that you think about yourself. Has anybody ever gotten like maybe your confidence, like your educational self-esteem gotten a little bit bruised in this prep process? I will tell you mine did. I always felt like I never, not that I never had to try, but I always did feel like things came pretty easily to me until it was time. Until it was time to prepare for these tests, and then it got a lot harder. Nobody, y'all gonna leave me hanging? I'm the only one who got their feelings hurt by test prep. I know that's not true. It's Chloe's time. You don't have to shout out, but I know it's not true that I was the only. Thank you, Annette. Thank you for not leaving me hanging there. I don't want to be the only one who got their ego bruised in this process. Listen, it's hard, right? And there are times when you start to think, well, maybe I am not so good at science. Oh, Carol, I hear you. Like maybe, thank you, Mika. maybe I'm not so good at science. Maybe this is not my right path. Maybe this is not the thing that I should be working on. None of that is true. It's just the test is looking for something different. In the past, the tests that we've taken have been science tests. And so we're able to learn the content and show our understanding of the content. They're asking you here to take the content that they expect that you already know. How do we know that they expect you already know it? Let's go through that again. What do they have already in their pocket to prove that you know science? When you apply to medical school, what do they have? Because they wouldn't need the MCAT if it was just about, does the student know science across these various topics? They don't need the MCAT. They have something else from you. They have your GPA, right? And they have a very clear set of prerequisites to go and attend their program. So you have to have taken those classes. They have your transcript, they have your GPA, they have your science GPA. They know how you are at science, right? This test is about taking what they expect you to already know. So that's like a check mark. They're like, that's a given. And they're saying, can this student think critically? Is this student a good problem solver? What if we mix the sciences together? Is that going to confuse the student? What if we put a bunch of mumbo jumbo on top of it? Is that going to confuse the student? Because they're looking for people who are going to be doctors, problem solvers, people who see patterns, people who are not easily overwhelmed, people who have a whole bunch of endurance. And so preparing, once you're able to say, this is not a science test, once you're able to say that and really believe it and really understand it, you can then change, okay, well, you know what? It's not just about science. So how do I prepare for that? How do I prepare myself for problem solving? Well, you practice problems, actual problems. You take your science knowledge that you know, feel free to have your content book open right there so you can refer to it as needed and work the problem so you can learn to be a problem solver, right? Show them that you're good at reasoning. When you do a practice problem, instead of just answering it and then checking to see if you're right, like you're just testing yourself all the time, why don't you also write what's wrong with each of the wrong answers or what trap you think they were trying to trap you in? This is especially helpful in cars. So there's a lot of different things that can change in your prep to get you points a lot faster when you can understand that. So I've just been very excited to see, and we talked about it yesterday, that so many of us were like, oh yeah, this was the moment. I remember the day when I realized it was not a science test. And for some people, that moment never comes, and the increase in score that they're looking for also does not come, and that's unfortunate. So I was very glad to know that that's not going to be any of you. So today's class, we're very familiar teacher. Teacher Petros is back with us again from yesterday's lesson. And he's going to be teaching us all about light and optics. This is actually another one of my very favorite Kaplan lessons because as you guys saw with the kidney, Kaplan has some really great visuals that really help you to understand things that like no teacher and no explanation that I've seen anywhere else has like ever helped me to understand. And this lesson has a few of those great graphics as well. So I'm super looking forward to you guys getting to share in that. I will be back later. I'm going to close down my email poll. Don't worry, I'll put it back up later. Make sure that you enter your email because you're going to receive handouts. Shout out if you've received your post-class emails as well. Who's getting emails? Who did their pre-class quiz? I love that little quiz. It gets you really thinking, you know, outside of the box. It's just meant to, it's not like a quiz. It's just meant to warm up your brain. Yes, Valeria, Megan, Kat, Sosiana, good. I'm glad you're all getting your emails. A lot of emails have been going back, and I've been getting a lot too, and responding, and it's been going really well. So those of you who are new, make sure that you enter your email because you're going to get handouts from Kaplan. You're going to get, if there's any specific notes that we need to pass on, those will go on there. I like to also send something that is kind of like a primer to get you thinking about the next night's lesson. So all of that will be coming. And this, I think, isn't tomorrow emulsion. So we'll be sending some stuff for that. So make sure that your email is in the poll. That said, I am closing it down now. So if you don't get it in quick, it's okay. I will bring it back up later when we come back for plus coaching. When we're talking about retention, and we're going to wrap it around MCAT, but also the ideas and the topics that we discussed are tested on the MCAT. So a little MCAT for your MCAT. Right now, it's time to go hang out with teacher Petros and see some of those great graphics I was telling you about. You can tell me later how you liked them. See ya.
All right. Let's see if the camera will work. Hi, everybody. How's it going? Let's see if this thing will turn on. You know it's live because. Okay, hold on. Give me 1 second. Try this again. I think we're going to be okay. There we go. All right, we're good. Camera's good. All right, perfect. We can turn the camera back on. Hello, everyone, and welcome. Welcome back. Thank you, Allie, for giving us our intro and really kind of getting everybody warmed up and ramped up. Who is excited about light and optics? Be honest. We're all friends here. I'm not going to tell anyone. Allie's excited about light and optics. Anybody else excited about light and optics? You should be. Here's the deal. Light and optics, I saw from the chat that a couple of you had never actually had light and optics in your physics classes, which is actually kind of normal. It tends to be one of the last topics that is in a physics syllabus, and sometimes professors will skip it selectively. I know that's the case in many instances, and then sometimes there are professors who's like the first thing that they teach in a second term of light and optics. So we're going to go through light and optics today at the level that you're going to need it for the MCAT. I want to be very, very clear about that. This is the level that you'll need it for the MCAT. It is a popular topic, but the thing to also keep in mind, Ali showed you that chart earlier today about kind of the different sections and the different topics that are tested on this exam. The MCAT is a very, very integrated exam in the sense that they will test you on multiple subjects in one section, but even within a question or within a passage. So while you may have learned light and optics in a physics class, they are going to apply light and optics. What's the organ system that would logically make sense that they would apply light and optics to on the MCAT, potentially? Where would be what's a good source, good area? I'll give you a hint. Starts with the letter E. You can all type in your answers. Not a trick question. I see a couple of you are typing in the eyes, and you're absolutely right, right? So, you'll see that. But here's the other thing, and this is just a fun fact for you. They might try to confuse you and make it look like the question is about the eye, but really it's just a light and optics question, right? You don't actually need to know anything about the anatomy of the eye per se to answer the question. So be very, very mindful of that, right? But as you're taking the exam, and this is true in other subjects as well, be very mindful of that it's about the application of this science to the scenario situations that they are presenting to you at the time on the test that you need to be concerned with. So here's what we're going to do. We're going to do light and optics. This is very similar to our light and optics session that is on the MCAT channel. So MCAT channel is something that we have as part of our comprehensive program. So, if you're in one of our courses or if you'll be in one of our courses, you've seen light and optics. But before we do that, actually, I'm just curious to know who is testing this Friday or Saturday. Let us know in the chat. It's going to be a lot of you, I'm sure, a few of you. But if you're testing this Friday or Saturday, that's it's very close. So you're kind of leading up onto those last couple days before the MCAT. Yeah, I see a bunch of you are testing this week. So good luck on the exam. Use what we're talking about here as as an opportunity to practice. But at the same time, if light and optics is an area that you're struggling with, that's okay because it's not super high yield, but it is high yield enough, right? It's something that you want to get a good little refresher on as we go. All right, let's dive in. So here's what we're going to cover. We're going to talk about the different components of the electromagnetic spectrum. So we'll talk about the different properties of good old visual light. And we're going to talk about ray diagrams. Ray diagrams are one of those things that sometimes they're, getting little nightmares. Anybody get nightmares about ray diagrams? Let us know. We'll talk about ray diagrams and really the understanding of what is reflection, what is refraction, what is a converging system, what's a diverging system, what's a mirror, what's a lens, and then what's a converging lens, what's a converging mirror, right? We'll talk about all the different combinations of those pieces as we go. So that's what we're going to be ultimately looking at here for today. So let's talk first and foremost about the electromagnetic spectrum and visual light. So when you think about the electromagnetic spectrum, it's a very large spectrum, right? There's a full range of waves that fall into the electromagnetic spectrum, starting, from your long radio waves over here on the right-hand side of the screen, all the way over to the left, and your gamma rays, right? So we've got a lot of different rays, lots of different types of waves of light that we think about. But when we really think about light, we oftentimes associate that with the visible spectrum, right? The part of the light that we can see, which is essentially the colors of the rainbow, right? That's this little narrow band, and this band is actually much narrower than the picture represents here. This is the visible spectrum of light that we really are going to be tested on quite a bit on the MCAT. You're not going to get a lot of questions about microwaves per se or about radio waves per se, maybe a little bit of the sound questions and such. But for today, we're really going to be focusing on this visible spectrum of light, the part of light that we would ultimately see. And the first thing that you need to get comfortable with, and I want to be very clear about this, and I want you to write this down and never forget this, is that it is an inverse relationship between frequency and wavelength. Frequency is represented by the letter F. Wavelength is represented by lowercase lambda, right? So that's the little squiggly lines that you see. That's a lambda symbol. It's an inverse relationship. As the frequency goes up, the wavelengths go down. You get shorter and shorter wavelengths with the increase in frequency. You get longer and longer wavelengths with a decrease as far as the frequency. And that relationship is going to be a relationship that's going to show up over and over again. And the reason for that relationship is because the speed of light is considered to be a constant, right? We think of light, we think of it as being a constant value. And so the speed of light, c, is equal to the frequency times the wavelength. And in order to keep this value over here constant, if this frequency value is going up, then the lambda value is going to be going down. And that's constant within any given medium, right? So you can slow down light, you can speed up light, but it is in any one medium, that value is going to be a constant value. And so the frequency as it goes up, the lambda value has to go down and vice versa. So really important to understand that relationship between the two. Now, when we think about this decreasing frequency, what that also means is a decreasing energy as far as the light waves are concerned. So that decreasing frequency, decreasing energy is going to be an increase in the wavelength. Easy way to remember this is over here, of course, you've got your radio waves. Over here, you've got your gamma rays. Gamma rays have a much higher energy than your radio waves go. There's a reason why we use radio waves to transmit music over the airways, although we don't really listen to music over the radio that much anymore, but that's how that works. I mean, your cell phones are operating essentially on a radio wave type scenario. But you think about this, and you think about the kind of the energy levels. You don't want to be bombarded with gamma rays, right? That's not a good thing for you. You don't want to be bombarded by even UV rays, right? The first thing we do, of course, is we put sunscreen when we go outside. So at the top here, you think about it, decreasing frequency and energy is an increasing wavelength. The opposite is true on the other side. So as your frequency increases, your energy increases, and of course that means your wavelengths are decreasing as we're going through. Now, this little spectrum here, this little visible spectrum that we care about, the rainbow, really is the key. So to the left, you've got UV light and UV rays. You've got X-rays, you've got gamma rays. And over on the right-hand side, you have infrared, microwaves, and then all your radio waves, starting from AM waves, the waves that we use for AM radio, to FM waves, and of course, even the waves that we use for our cell phones fall over in this side. So when you cook your food, you're using light essentially, you're using these, or you're using part of the electromagnetic spectrum, right? You're using microwaves as part of that process. Important or a nice easy way to remember the order of the rainbow. Remember that UV is on the left, infrared, the R in IR is on the right. And if you remember that the UV is on the left and the R is on the right, so R for right, then you remember that red is over here, the purple is over here, and then it's just a matter of all the combinations, right? So purple, and then you got blue with the yellow will give you the green, so you got the green, then you got the yellow, then you got the orange, and you got the red. So when you were in kindergarten or in preschool, remember you mixed all the colors, right? You figured out the different colors and how to get to the different colors. That does actually help you on the MCAT. So who thought that kindergarten or preschool even would have helped you on the MCAT? It will help you on the MCAT, but you just have to remember which direction this rainbow is going to ultimately be moving along the way. All right, so that's kind of what we're going to be looking at. Now, when we care about visible light, and we look at visible light, this very narrow spectrum here, these are represented in nanometers, right? So we have 750 to 380. So very, very tiny range, if you will, as far as our spectrum of visible light. Now, when all of these colors are together, what color of light do we ultimately see? So when we bring all the colors together, what are we ultimately seeing as far as the color of light? If I blend all the colors of light together, what do I end up getting? It's different from when you mix all the colors of paint together, of course. But you see good old white, right? You see good old white. So they all cancel each other out and you end up with a nice white light. Now here's a little top tip, something to remember. We'll use this later on here today. I'm wearing a blue shirt, all right? So the white light that's in the room is hitting my blue shirt. What colors is my blue shirt absorbing? This is true for you as well. What colors is my blue shirt absorbing? It's a little get you thinking question. What colors is my blue shirt absorbing here? That's why you're seeing it as being blue. Go ahead and type in the chat. It's everything except for the blue. Exactly, right? So every color, my shirt, my blue shirt, is literally absorbing every color of light except for blue. It is reflecting the blue light, which is why you see it as blue, and that's true for any color. So when you see something that is yellow or you see something that is green or whatever color, what that is saying to you is that every other color is being absorbed by that material except for the one color that you're ultimately seeing, which is one of these wavelengths, right, along the spectrum here that's being reflected back out at you. Okay, so that's the way to be thinking about the light. Now, this whole formula of C equals F times lambda, we see the decreasing frequency is the increasing wavelength. We have red over here on the right, we have the violet on the left, and then all the colors in between, right? So we've got blue, green, yellow, orange, and our good friend red on the other side. So that's the way that we look at these and the way that we see the different colors along the spectrum. Now, how is this going to be tested? How does the MCAT ultimately test it? We're going to do this problem here together. One thing I didn't say at the beginning, which I will say now, is we're going to look at a couple problems here together. These questions themselves will never actually show up on the MCAT. Questions very similar to these will show up on the MCAT, but this question itself will not show up on the MCAT. So what I want you to really focus on, what I want you to put your kind of mind energy towards here today is the process that we're going to use to answer these questions, which is why we're going to do this first one here together. So here's a very, very classic MCAT style question. It says, elevated wakefulness has been heavily tied to exposure to blue light, which results in the depolarization of the noradrenergic fibers in the locus coeruleus via the opening of the nonspecific cation channel rhodopsin 2. Now, you tell me, you read that first sentence. Have they actually asked us a question in that first sentence? Yes or no? Plain and simple. Yes or no? Did they ask us a question? And I see a bunch of you are typing in. I'm guessing I know what you're typing in already. It takes a couple seconds for me to see what you've typed. You're saying no because it's no, right? They didn't actually ask you anything. They've given you some information. They've given you all this very confusing language. Maybe you have, seen the locus coeruleus before somewhere, right? Maybe you've seen channel rhodopsin 2 somewhere. But these are biological terms that may or may not be relevant to actually answering the question. So don't be fooled. Don't let the kind of structure of the way these questions are phrased sometimes throw you off. So then the question that they're actually asking you is, which of the following ambient settings would be least effective in supplementing the treatment of insomnia? Now, insomnia, of course, is the difficulty in falling asleep. What did they just tell you is bad for or will cause elevated levels of wakefulness? They just told you this. They told you this in the previous part. What did they tell you was not good for you? What color of light? They told you that blue light was bad. So if I want to help somebody who has insomnia, do I want them to have a lot of blue light around them? What do you think? Absolutely not, right? That's why it's not good to sleep with the TV on. That's why it's not good to be, looking at your phone when it's dark at night, right? So these are all the reasons why we have the features that we have today on our technology to get rid of as much blue light as possible. So the question saying, which of the following settings would be least effective? Really what the question is asking you is, which of the following answer choices falls into what color of light? You tell me. What are they really asking you at the end of the day? And this is part of that process. And again, you wouldn't spend this much time answering the question, but I want you to really kind of grasp this process of how to interpret, to decipher these questions. And they're really asking you at the end of the day, which ones of these is blue? Exactly, right? That's really what they are asking you. At the end of the day, that's the question behind the question. 9 times out of 10, doing well in the MCAT is about being able to identify the question behind the question. That's really what it comes down to. So if we know that lambda times the frequency is equal to the speed of light, we know that the speed of light is 3 times 10 to the 8 meters per second. That is the one that you need. That is a number that you need to know going into the test. So know that number, 3 times 10 to the 8 meters per second. If we want to solve for a lambda, we're going to say, all right, lambda is equal to C over F, excuse me. So it's going to be 3 times 10 to the 8 over the frequency. So we're going to solve it this way. But then we have to ask ourselves, and this is where your content knowledge is going to come into play. They don't give you the wavelengths of the different colors of light. You need to know where blue light falls on that spectrum. So we know from the previous picture, and we know from our previous knowledge, that blue light has a lambda, has a wavelength of around 400 to 500 nanometers. So in theory, if we were to say, all right, let me put that value in for my lambda, I should be able to solve out the frequency that is going to be bad for us, right? That's really what's happening here. So instead of having it as lambda equals 3 times 10 to the 8 over F, we're really going to have that the frequency is equal to 3 times 10 to the 8 over the lambda value of blue light. We'll pick a number that's in the middle. We'll say, it's between 400 and 500. So we'll say 450 nanometers. 450 nanometers is 450 times 10 to the negative 9, which in proper scientific notation would be 4.5 times 10 to the negative 7, which is what we have down over here. So we're really going to solve for the frequency. So we got 3 times 10 to the 8 divided by 4.5 times 10 to the negative 7. Now here's the deal. We don't have a calculator on this test, so we got to do a little bit of math without a calculator, and that's fine. Here's how we do it. We say 10 to the 8th divided by 10 to the 7th, 10 to the negative 7th, that's going to be 10 to the 15th, right? You add or you subtract the exponents when you're dividing by an exponent. So 10 to the 8th divided by 10 to the negative 7 is really like saying 10 to the 8th minus negative 7, which is 10 to the 8th plus 7. So that's going to be 10 to the 15th. 3 divided by 3 would have equaled 1. 3 divided by 4.5 is really 2/3, right? So 3 divided by, think of it as 30 over 45, that's 2/3. So really what we have over here is we have 0.66 times 10 to the negative, or 10 to the 15, which we can move around our decimal points to make it proper scientific notation, and we end up with 6.5 times 10 to the 14. That's the frequency of the blue light that would be bad. We then look through the answer choices, and you find the one that is closest to this value. And the one that's closest to this value, I see that D is the most popular answer. You'd be absolutely correct. It's answer choice D. Now, if you were looking at A, the problem was you saw the 6.5 and you saw this 6.5 and you think, oh, that looks really good, but your exponents were off. This is off by an exponent factor of 10, right? So this is, 10 to the 13 versus 10 to the 14. That's a factor of 10 as far as the difference is concerned. So the correct answer on this one is answer choice D, but really the process here, and this is just what it comes back to, did you actually need to know anything about channel rhodopsin 2? Did you need to know anything about the norandrogenic fibers or the locus coeruleus? Absolutely not, right? This is extra fluff that was put into the question. It was put in there to ground it to the biological sciences, but in reality, this is a question that is asking you about this very, very simple formula. So really being able to decipher the value or decipher the question, that's what's going to be key for you along the way. And that's how you're going to be successful on this exam. So something to keep in mind, it's a skill to practice. It's a skill that does take time, but something that is pretty important along the way of really learning how to interpret the questions. I can't stress that enough with my students, and I can't stress that enough with you. You're all my students today, and really important to make sure that you're in that mode. If you got questions about that, please do let us know in the chat. We'll be more than happy to answer this for you along the way. Let's go ahead and take a look at the second learning goal, which is all about light rays and ray diagrams and everyone's favorites, right? Everyone's favorite thing. So here's what we're going to do. We're going to go through all the different scenarios. Okay, so we're going to go through all the different scenarios and really understand how we're going to use these ray diagrams to understand what's going on with the light. And the first thing that we have to look at is we have to look at reflection. So imagine that you have a light ray and it is going to hit what's referred to as being a plane mirror. A plane mirror is a flat mirror. Okay, so like the mirror that you look at in the morning and you're brushing your teeth, you're combing your hair, right? That's the mirror we're talking about. When you have a ray of light coming into this mirror, it is going to be reflected, and it's going to be reflected at a very, very specific angle. And the angle that we care about, this is the first kind of big mistake that a lot of students make. I know I've made this mistake in the past when I was first learning this stuff, so completely normal. The angle is relative to the normal line. We don't care about the angle relative to the plane. We care about the normal line. The normal line is defined as being the line that is at a 90-degree angle to our surface. So this normal line here, relative to the ray line, is going to give us an angle of incidence. That's this theta 1. And theta 1 is going to be equal to theta 2 when we have this perfect reflection. So this angle here, theta 1, is equal to theta 2, and that's the value that we care about, right? So we care about theta 1 equaling theta 2. All right? So this is the easy one. So if you see a question on the test and it's about a light ray coming in and hitting a plane mirror, it's being reflected back, theta 1 equals theta 2. The angle of incidence, which is theta 1, equals the angle of reflection, which is theta 2. Okay, that's the simple one. So that's what we call the law of reflection. Plane mirrors, so mirrors that are flat, always create what we refer to as being a virtual image. And this is where the confusion begins. A virtual image is an image that is inside the mirror, right? When you look at yourself in the mirror, you see the image, but the image is in there, right? It's in there. Anyone ever have that experience, right? You're looking at yourself and you're like, oh, I'm in the mirror. That is a virtual image. A real image would be an image that would be behind you and actually in reverse. So when you look at yourself in the mirror, you're up, you're standing up in the mirror you're standing up. If it was a real image, it would be an image that would be behind you. And we'll see how that can happen here in a second. We're going to take a look at that in a bit. But these are always what we refer to as being virtual images. So they're creating virtual images along the way. Now, when we look at mirrors and when we look at these angles and we look at reflection patterns and all those bits, what we have to look at is we have to look at this from the perspective of where our original object is. And we care about our focal point, and we care about the direction in which the light rays are going. So here are some definitions, some terms that you need to be familiar with. The F value is the distance from the focal point to the center of the mirror. The C value is known as the radius of curvature. So that's the distance from here, this radius of curvature, from here to the actual mirror that we're looking at. And then if we're looking at this from the perspective of where we're placing the object, if we place the object between, or behind, I should say, the focal point, what we're going to end up with is a pretty cool scenario. So we're going to walk through this, and here's how we do ray diagrams. So number one, you're always going to draw a line that is the distance from the object to the mirror itself. Okay, so we're going to care about this as we move forward. So this is what we refer to as being the object's distance. Now, knowing the object's distance, knowing the focal point, and knowing where the image's distance is, which is referenced as little I, knowing these three values, the F, I, O values, actually helps us solve all sorts of problems, right? So when we look at this, we say, okay, if we want to figure out the focal point of something, 1 over F is going to equal 1 over the distance O plus 1 over the distance I, which is equal to 2 over the value R. So take a moment and write this formula down, because this formula is going to be a formula that we're going to see over and over again on the MCAT. So anytime you got questions that deal with optics, you're going to see this value or this formula all the time, and this is going to save you lots and lots of points, right? Lots of opportunities, lots of missed opportunities can be saved using this little formula. So write this thing down. Don't forget it. Maybe we can, I don't know, Gina. We got Gina, Hannah, Henry, Mackenzie, Paul here. One of them. Maybe you can put that into the chat so we can all have it there. Now, we like this formula for a variety of reasons, and we also like the magnification formula. The magnification formula is the I value divided by the O value and the negative of that. So the magnification, how much something is magnified or minimized, is equal to the negative of I over O. Okay, so these are our two kind of fundamental formulas that we're going to come into play on this. See a couple questions that are coming in about the C value. The C, that is your radius of curvature. Okay, so when you're looking at a mirror, and we're going to get to this here in a second, but when you're looking at a spherical mirror, not a plane mirror, right? Plane mirror is a flat one. When you're looking at a spherical mirror, it's got a curve to it. So the flatter the curve is, the bigger my radius of curvature is going to be, right? As opposed to the tighter the curve is. It's going to be a smaller radius of curvature. So imagine if you were to take a piece of string and put it here and then stretch it out to the center of this lens, and then you have a pencil attached to it, and you were to kind of rotate it back and forth. That's how you would end up with the full circle, right? So really this radius will give you the full circle. So if this C value was closer here, you'd have a tighter lens, a lens that would have a tighter curve to it along the way, or vice versa, right? If you had it further away, it'd be a bigger radius of curvature. So that's what that C value is. So we reflected it, we call it C here, but it's really this radius. It's the radius of curvature. That's what the C is. So radius of curvature. That's that C value that comes into play there. Okay, so it's all relative to that center line of the lens along the way. Now, concave mirrors, which is what this guy is here, concave mirrors are also known as converging mirrors. So don't let those two terms trip you up, right? If you're a concave mirror, it's a converging mirror. I can use them interchangeably, and it means the same thing. There's no difference in this. And a convex mirror is a diverging mirror. So a convex mirror would be one in which, you know, the light rays are going to hit. Imagine if this one's like this, there's a convex would be shaped outwards like so, and the light rays are going to diverge away. Now, what converging means is that the light rays will converge upon each other. What diverging means is the light rays are going to diverge from each other, right? So if imagine, you know, a road, and you have a converging roads, that means the two roads come together. You have diverging roads, that means they go apart. So that's what the diverging and converging mirrors are representing as far as the terms are concerned. So let's take a look at a couple different scenarios, the scenarios you'll need to know as far as the MCAT. Here we have a good old mirror. So we're not going to look at lenses just yet. So no lenses yet. We're looking at mirrors here. And what we're going to do is we are going to place an object, and it's going to be placed between the focal point and this radius of curvature. So it's behind the focal point. That's the key, is that it's behind the focal point. So we put it behind the focal point, and the way we're going to draw the ray diagrams, we're going to draw two of them. Okay, we're going to draw two rays. We're going to draw one ray that is parallel to the axis, and as it's parallel to the axis, it's going to reflect back through the focal point. That's the ray that we are going to first care about. The second one we're going to draw is to the center of the mirror that is going to reflect back at the same angle. So there it goes to the center of the mirror, and it's going to reflect back at the same angle. So remember that angle of incidence, angle of reflection here, because we're drawing it to the center of the mirror. Right here, where these two lines cross, where the red line crosses the blue line, that is where we are going to end up with something very special, which is our image. Right? That's where the image is. Now notice that this image is upside down, right? It's an upside down image. So that's interesting. So if you're looking at the mirror, you don't see yourself in the mirror. If you're looking into this mirror, you don't see yourself in the mirror. Where would you see yourself? In order to see your image, where would you need to look? Where would you need to look in order to see your image in this first scenario? Go ahead and type that into the chat. Gotta look behind you, and you gotta look down, right? So you're gonna have to look behind you, and you're gonna be upside down, right? So you're gonna look in front of you, you're gonna see nothing, you're gonna look behind you, and you're gonna see your image. That image, imagine you got a screen behind you or whatever, that image is a real image. Right? It's a real image. It's an image that is there. It is not inside the mirror. It is actually outside the mirror, right? It's light that's being reflected backwards. So this image would be considered real. It would be considered inverted, and it would be considered magnified. Notice that it is going to have a larger height than the original object had. Okay, so this is pretty much how old-fashioned cameras work, right? This is essentially what's happening, is that you've got this image that is flipped around on the other side, and this is how we're able to magnify images along the way. Okay, so that's what we have going on there as far as this first image is concerned. So that's scenario number one. Scenario number two, so here I put the object behind the focal point, and I was able to invert it, and I was able to get a real image. Second scenario, we're going to put the object onto the focal point, and we're going to follow the exact same rules as before. So nothing has changed as far as our rules go. We're going to draw a parallel line, And that parallel line is going to reflect back, and it's going to reflect back through the focal point. And we're going to draw a line from the top of the object to the center of the mirror, and it's going to have whatever angle this was, it's going to have that angle of reflection. So there we go. And what we end up with is we end up with parallel lines. We end up with these parallel lines. These two lines will never converge upon each other. So this image is considered to be a real image, but it's a theoretical real image. It will only be a real image at infinity, meaning I have to look as far back as I can behind me, and then more, and then more, and then more, and then more, and then more. Infinity is a long way away when you think about it. Only at infinity will you ever see the real image that's there. It will be inverted at infinity, and it will be infinitely magnified, right? It will be this huge magnification because it's going to take it's going to take an infinite amount of distance in order to be able to get to the point where the two lines will ultimately cross themselves. So this is a theoretically, it's a real image, but it's theoretically real at infinity, right? So if anyone ever gets to infinity, give me a call. I'm curious to know what infinity is like. I've always been curious to know what infinity is like. So that's my corny physicsy joke for the night. All right, so that's also how magicians make objects disappear. In all seriousness, when they say, "Oh, it's all smoke and mirrors," this is the mirror that we're talking about. Because oftentimes, what a magician will do is they'll put an object right at the focal point, and then they'll be showing you the mirror, but you think the mirror is actually a real thing or a real place, and then the object is gone, and you go, "Oh my God, it's gone! How did that happen?" Well, it's because they used mirrors, and there's oftentimes smoke involved and music or something to make you really believe that it has disappeared. All right, let's look at the third scenario here. And if you got questions about any of this, please do let us know. Third scenario here is you've got an object, and now instead of being behind the focal point or at the focal point, it's in front of the focal point. So it's getting closer and closer to this mirror here. So we're going to do the exact same thing, right? I'm going to sound like a broken record. We're going to draw a parallel line. We're going to draw that line from the mirror back through the focal point. We're going to draw another line from the top of the object to the center of the mirror. And again, it's going to have a reflection just like so. Problem is, these lines never will cross. So if we were to extend these lines this way, they will cross, they will converge upon each other, but they'll converge on the inside of the mirror. So what direction will this object be pointing? Remember, the real image, the object was pointing down, it was behind us. Now the image is going to be in front of us. What direction is it pointing in? Not a trick question. What direction is this thing pointing in? Where is it going? A couple of, it's in front of us, and it's pointing upwards. Exactly, Lauren, right? It is an upright image that's in front of us in the mirror. Now, if it's in the mirror, then this is what we refer to as being a virtual image, right? So this is a virtual image. It is upright, and it is magnified. So here is a rule. Here is a definition that you can write down for converging mirrors. If the image is real, it is pointing downwards. If the image is virtual, it's pointing upright. So if I came to you and I said, "Hey, I've got a converging mirror and I've got an upright image," you can immediately say to me, "Petros, you've got a virtual image," right? You don't need to do any work in order to be able to solve that out. You know that right from the get-go, right? So virtual is upright, real images are downwards. Okay, so write that down. Don't forget that. Use that to your advantage because you can save yourself a considerable amount of time by remembering that that bit there. Okay, having fun so far with ray diagrams? Yes, no, as much fun as we could be having with ray diagrams. And seriously, let us know what questions you have, because this stuff, especially for those of you that haven't had this before, this might be a little bit new, and you might be looking, going, where is this all going? I will say this much: this does take a lot of practice, and by practice I mean just doing problems. Really, it's not about just memorizing that; it's about actually working through problems and making sure that you're actually engaging with the rules in order to make this. That makes happen. Good. I'm glad you guys are having fun. As interesting as the topic is, sometimes it's it's a little bit like, okay, that again, another line, another ray diagram, all that good stuff. All right, let's look at the next scenario, and this is, notice, I'll just look over here. Here we have a concave mirror. Now we have a convex mirror, right? So things have all of a sudden changed on this one. Okay, things have all of a sudden changed. So again, we're going to put our object here. We're going to take a look at this from the perspective of the same rules as before, right? We're going to draw our lines. We've got our angle of reflection on this one here. So that's from the top to that center back over here. We put this line up over here, but I didn't draw it through this focal point here. Rather, this goes this way. And the reason for that is because we are going to extend that line to go through the focal point, which is on the other side, right? So for a diverging mirror, we've got the focal points on both sides that we care about. In this case here, we're going to put it over, it's going to come through on this guy over here. And as a result of that, what's going to happen is we're going to extend this line as well. And this is where we're going to get that, intersection, if you will. And so what we have going on here is an image that is upright, right? It's an upright image. And it's an upright image. And of course, if it's an upright image, what kind of image is this? This is not a trick question. This is more of a, were you paying attention? So if I've got an upright image, you should instantaneously be able to tell me. Type it into the chat, make us proud. I might have a prize for you. It's an upright image. It's virtual. Yes, it's virtual, right? So this is a virtual image. And we know that it's a virtual image because we see an upright image. The difference here, though, is that notice that the initial lines that we drew, as far as the lines of reflection, were diverging away from each other, right? This blue line is going about as far away as it can from this red line. They converge on the inside of the mirror. So this is a virtual upright image, and that in this case has been minimized. So very nicely done. I'm glad you were paying attention. Since you were paying attention, you get a prize. I wish I had more of a prize to give you than this, but hey, it's better than nothing, and that is you get a nice green star. So very, very well done. I'm stingy sometimes with my green stars, but tonight you got those for sure. All right. So bottom line, we looked at 4 scenarios here. We looked at the object between C and F. We looked at the object at the focal point. We looked at the object between the focal point and the mirror, and we looked at a convex mirror diagram. So we looked at the 4 scenarios that you're responsible for as far as the MCAT is concerned. So you've now got everything that you need as far as these scenarios are concerned for this test. All right. So if you got questions about that, by all means, do let us know. But that's mirrors. But there's also something else, and that is something that maybe some of you wear on a regular basis, glasses, right? So some of us wear glasses, and even if we don't wear glasses, we've got lenses that are in our eyes. So we're going to look at lenses here in a second. But before we do that, we're going to try a question out. So I'm going to give you guys 1 minute, just 1 minute. We're going to put a timer up, and there's a poll that's on the screen that is open. So I'm going to give you guys a minute, and I want you to try this one out on your own. So good luck. You've been given all the information that you need in order to solve this. Even though it's about a lens, you have everything you need in order to solve this problem. Good luck. A little bit of a challenge. All right, so let's take a look at this here. So let's. Paul's going to give me the answers, or give me how you did on the poll there. But let's walk through this. So remember this formula that I showed you earlier: 1 over f equals 1 over I plus 1 over O. The image of the distance of the image and the distance of the object. That's the formula that we care about here, because they're asking us, they're giving us numbers. They're saying the object stands 12 centimeters from the diverging lens. If the image is formed 2 centimeters from the lens on the same side as the object, what is the focal length of the lens? So they've given us all the data, all the information that we know. So we want to figure out the focal length. We say 1 over f equals, now it's 1 over -2. And the reason why it's 1 over -2 is because it's on the same side as the object. If it was on the opposite side of the object, it would be 1 over 2. But it's going to be 1 over -2 because it's on the same side of the object. And then the object is 12 centimeters, so 1 over 12 over here. All we have to do now is do a little bit of math, right? This is all math at this point. It's all algebra. So we've got 1/12 minus 6/12. So we're really going to end up with -5/12. So 1 over f is equal to -5 over 12. But then we got to flip all these pieces around. So if you do the flipping and you do the math, you say, okay, I'm going to multiply through by 12. I'm going to divide through by -5 in order to be able to get my f value out of the denominator and into the numerator. I'm going to multiply through by f as well. And I'm going to end up with -12 over 5. So my correct answer is going to be answer choice A, right? So answer choice A is the value that we're going to end up with. Now, if you chose answer choice C, my guess is, just a hunch, my guess is that you didn't take into account this negative value, right? That's probably what happened, is you ended up with 1/12 plus 6/12, so you had 7/12, and you ended up with 12 divided by 7. And I see a bunch of you are switching now. 12 divided by 7 would give you 1 and 5/7, which is about 1.7, and that's why I ended up with C. So since it said that the image was formed 2 centimeters from the lens on the same side as the object, that's where we know we use the negative value. Okay, so that's the keys. You have to make sure that you know which side of the object you are, or where you are relative on the lens. Okay, so if you're on the same side as the object or on the opposite side of the object. Very good. So we got the F value there. Nicely done. Good. So that's this first little warm-up question. Let's take a look at refraction. So before we look at lenses, we got to look at refraction. The idea behind refraction is actually pretty simple. It's a little complicated, but it's a little simple as well. The idea is that since light is going to travel at different speeds depending on the medium that it's in, it's going to end up getting bent as it changes mediums. So when light's going through water and it goes, so if your light ray is starting here and it goes up to this surface where the water meets the air, and it meets the air and it goes over here, it's actually going to bend away from this normal line. So if you look at here, you got this value here. As far as an angle of incidence, this is your angle of refraction. It's going to bend away because basically what you have going on is you're going from a more dense medium to a less dense medium, right? That's the difference of what's happening between these cases. You're slowing, the light is slower here than it is over here. There's less resistance along the way. So you have the incident ray versus the refracted ray along the way. So when we look at these, we care about something called the index of refraction. So the index of refraction is really the measure, if you will, of how the medium is going to affect the speed of the light, how it's going to affect the angle at which the light is ultimately going to be reflected and ultimately going to come through into play. So this is what we refer to as being Snell's law. So when you think about Snell's law, really what you're looking at is you're looking at the relationship of how one index of refraction times the sine of theta is going to equal the index of refraction of the second medium times the sine of theta of the other medium. So they're going to equal each other, all right? So this should be n2 and s and theta 2. My apologies. We'll fix that. So really what you have going on here is you have these two values that are equal to each other, but if your index of refraction is going up, then this value here has to be going down, right, to keep everything nice and balanced and nice and even. Is really what you're caring about. So this is what we refer to as being Snell's law. So you can solve a lot of problems using Snell's law along the way. Now, when we look at a lens specifically, what's happening is you have the light ray going from here through the lens, and it's going to be bent. Either it's going to be converged or it's going to be diverged, depending on what the shape of the lens is ultimately going to be. So same exercise applies as we did when we were looking at mirrors. You've got the object, it's behind the focal point. You're going to draw two rays. You're going to draw a line that is parallel to the axis. And instead of reflecting, though, the difference now is that it's going to refract through the focal point. So here's what happens. You draw this line here, and you don't have it come backwards, because this isn't a mirror that is bouncing the light back at you. That's the difference between a mirror and a lens. Mirror is bouncing light back at you, whereas the lens is letting the light go through. What happens instead is you refract the light through the focal point on the other side. Okay, so the focal point on the other side is equal and opposite as far as distance on the two sides, but it refracts through accordingly. The second line, same as before, you're going to draw a line straight through the center of the mirror, and you're just going to keep drawing that line. And where these two lines meet is where you're going to end up with your image. Okay, this is how the lens of your eye works. You've got this converging of these two light rays. You've got an image, and that image is upside down. Now here's the bonus question for the night. Let's see if we're paying attention. We've got an image that's upside down. Is it a real image or is it a virtual image? What do you think it is? I know you all know this because we just talked about it. Good stuff. This thing is going to be real, and it's going to be inverted, and it's going to be magnified, right? So we've got a real inverted magnified image. This is how we see. So if you want to get real philosophical, excuse me, we know on the MCAT there are philosophy passages on the cars section, but you can get real philosophical with your friends and say, we see the world upside down, because technically we do. It's our brain that flips the images back upright, FYI. Right? So if you didn't know that, that shows up in the behavioral sciences a lot. Now, when we look at this, we have to think of this also in terms of the power. And the power, when we're looking at lenses, is defined as 1 over the focal point. So if you want to, so when you go to the eye doctor and they're trying to, figure out what lens you need, they'll oftentimes talk about, the power that you need as far as your corrective lenses. Really what they're doing is they're just looking at the inverse value of the focal point. So they're moving the focal point in order to be able to get things to go into play. Now, the real cool thing about lenses, and we're not going to go into this too much here today. We go into this in the MCAT channel a little bit more later on in the session. The cool thing about lenses, though, is that lenses, you add up lenses, right? So if you need a bigger prescription, when they're testing you out, oftentimes they'll have multiple lenses that will come in front of each other, right? So the nice thing about lenses is that really whatever image one lens forms becomes the object for the next lens. So if you've got two lenses, you really say, okay, I'm going to take that image and it's going to become the object for the next lens, and it's going to go through accordingly. So that's the way that we make these adjustments along the way. Cool stuff. So let's take a look at scenario number 2. Same type of lens. We've got the object this time, though, on the focal point itself, right? So remember, the first time we did this, just a second ago, the object was behind the focal point. Now it's on the focal point. We still draw the line straight to the lens. The line goes from the lens through the focal point, right? The refracted light goes through there, and then we draw another line right through the center. These two lines, once again, are parallel, similar to what we saw when we put the object on the focal point with the mirror. So this image is a real image, but it is real at infinity. Okay, very important to keep that in mind. It is a real image at infinity. And at the same time, it will be inverted since it is real, and it will be infinitely magnified. So same scenario as we saw earlier in the mirrors. Okay, so take a shot of this, or whatever it is that you need. These are all summarized quite nicely in our materials, so you'll be able to see this accordingly. But this is a kind of big part of understanding how these lenses all work. So third scenario, where do you think I'm going to put the object this time? So we put the object on the focal point, we put the object behind the focal point. Where are we going to put the object now? If you've been following along, you'll know where this is going to ultimately be. Where are we putting this thing? Where are we going to put it? We're going to put it between the focal point and the lens itself. So here's the cool part. Put that there. Same rules as before. Draw the straight line through the focal point. Draw another line through the center of the lens. Notice these two lines don't actually converge on the right side because they will converge over here on the left side. We end up with an image that is upright. And since the image is upright, you all know the answer to this already. It is going to be what type of image? Go ahead and type it into the chat. Make us proud. Make us proud on this one. This is going to be a good old, starts with a V, ends with an L, good old virtual image. Exactly. Very nicely done. So it's a virtual image, it's upright, and it's magnified in this case. Cool. Fourth and final scenario on lenses. We were looking over here at these concave lenses. Now we're going to convex lenses. Now we're going to look at this concave lens. And what we have going on here is we've got an object. We're going to draw the straight line. We're going to draw a line. So notice that this is going to diverge away. So we have to use this focal point on the left side for this ray. And then we, of course, will draw another line through the center, and it'll just keep going. So the image is going to be here. It's going to be on the same side as the object originally. It's upright. It's virtual. This is a diverging lens, right? So it's a virtual upright image, and it is minimized in this case. So depending on, in an application perspective, ophthalmologists, optometrists is what they do. So they figure out what kind of lens you're going to ultimately need. Do you need a diverging lens, a converging lens, et cetera, et cetera. But one thing that I will say, and important to kind of keep in mind and not get yourself confused. So here's another top tip for you. When we were looking at mirrors, the concave mirrors were diverging systems, right? The convex mirror was concave mirror was a converging system. The convex mirror was the diverging system. In lenses, it's the opposite. The convex lens is the converging system. The concave lens is the diverging system. So divergence and convergence just mean the direction the light's going, but it switches with lenses and with mirrors as far as the type of lens or the type of mirror you're going to need. So be careful about that, because that is a terminology that is very, very easily confused and oftentimes the source of many problems, and not problems by questions. I mean problems in the sense that we make mistakes because of those bits, right? So don't let that be your scenario in this case here. So with that said, let's wrap this up with a really, really cool final question. So Paul's going to put the timer up. We're going to give you guys a minute. We'll put a poll up as well. And let's look at this here. And this is one that deals with refraction. So take a moment and try this out. In fact, take 60 moments and try this out. Right. So, what do you think about this question? Easy, medium, difficult? Where would you rank this one? Got a lot of pictures. Patel, I'm happy that you've learned more physics in these last couple minutes than you have in the last 2 semesters. It's sad for the 2 semesters that you spent in physics, but it's exciting for how quickly you can learn something here, right? So that's the right. I hope that's the case for most of you, right? In this last, what is it, 50 minutes or so, hopefully you've learned a whole lot. But here's the bit, yeah. So you're not sure you got it right. That's okay. This is, it's like a medium level question. It's a medium level question. I wouldn't say this is super hard. I wouldn't say this one's super easy. But here's where they try to confuse you. They say a light ray with a wavelength of 60 nanometers enters a piece of glass. And immediately you're like, oh, 60 nanometers. I'm going to need that number, right? Because tell me if this is you. This is me. If I see a number in a question, I immediately think that I need to use it. Anybody else have that or fall from that symptom of, I see a number, I got to get a calculator, I got to calculate something out? Who else is like me on that one? Or like Gina or Hannah or Henry or Mackenzie. I think we're all this way, right, Paul? I know we've had this conversation. We see numbers, we're like, we want to calculate, right? This is a true fact. This is just how we are, right? We're all, we're samesies, exactly. This is just it. This is how we're programmed. And the reason for that, and this is something, a bit of advice that I'll give you, and this is teacher to student, so take this advice for what it's worth. But when we learn physics as undergrads, it tends to be very problem set based, right? You do problem sets, you submit them online, or if your school's still doing it the old way, you work them out on paper, right? And you go and hand them in at a certain time. So that's just how physics tends to be taught. It's very, very problem based, very numerically calculate things out. You get to the MCAT, it's all very conceptual more than anything. So a question like this says that you got a light ray with a wavelength of 600 nanometers, enters a piece of glass with an index of refraction of 1.5. I got news for you. It doesn't matter that it's 600 nanometers. It doesn't technically matter that it's 1.5, because air, we consider that to have an index of refraction of 1. That's the lowest index of refraction. All that matters is that the glass has an index of refraction that is greater than 1. Doesn't matter that it's 1.5 or 2 or 1.25 or 1.45. That's irrelevant. What matters is to know that when you're going from a low index of refraction, so here's the last kind of content piece I'm going to give you here. When you go from a low index of refraction to a higher index of refraction, you are going to see the light bend towards the normal line. If it's the opposite, you're going to see it bend away from the normal line. So here's how we have to think about this question. We look at this question, we look at our angles of incidence for all 4 of these. And we can do a little bit of elimination. It's actually kind of cool the way that we can think this through. Walk through this with me. Angle of incidence on A goes in and it bends towards the normal line. We like this one. For B, it moves away. So we can get rid of that one right from the get-go. We don't even care what's going to happen on the other side. Over here with C, it goes in, it bends towards the normal line. We like that one. We look at D, it goes in and it moves away from the normal line, so we can get rid of that one, right? So all we've done here is eliminated 2 answer choices. We've gotten rid of D and we've gotten rid of B, and we haven't even done any math on this one. Now all we got to do is look at the second scenario when it's going from the glass back out to the air. It's not going to bend even more towards the normal line. It's going to bend back to where it was originally. So that means that C is out, which means the only answer that we can choose on this one is going to be answer choice A. And that's how that's as simple as that. There was no math. It's understanding the one basic concept. You didn't need to use Snell's law. You didn't need to do anything. All you needed to know is that you're going to bend towards the normal line when you're going in towards, or when you're going into a higher index of refraction. Now, you could have used Snell's law. That's fine. You could have said, okay, my N1 is 1, my N2 is 1.5, therefore, this angle has to be a bigger value than this angle is, right? You could have done that. You could have said, okay, my theta 1 is going to end up being a bigger value than my theta 2. That's fine. You could have done that. However, you don't really need to do that. You don't always need to do that. So, do the work you need to do. That's really what it comes down to. The advice that I give to every student that I run across, I'm giving this to you. You're now being indoctrinated into the club. I've had tens of thousands of students the last 19 years, teaching the MCAT here at Kaplan. I can tell you this for a fact. Be efficiently lazy. Do the work that you need to do in order to solve the problem. That's the key. That's the key to all of this, is do the work that needs to get done. If we look at a problem like this, this is irrelevant. Technically speaking, even this is irrelevant. All we need to know is that this value is greater than 1. That's all that mattered to us as far as solving this problem and knowing that the path is going to look the way that it looks. And the correct answer is answer choice A. And it looks like the vast majority of you have chosen answer choice A. So I know I said that I was stingy with my green stars. I'm not as stingy as I make it sound, and this time I'm going to give you a gold star. So you did very, very nice there on that last problem there. So what we've seen here today really are 2 fundamental concepts that are going to show up quite a bit as far as light and optics are concerned. There are others. There are other bits that come into play. This is not everything. This is not exhaustive as far as all of light and optics, but these are the key kind of fundamental players that you'll see a lot of on test day. And again, it's about making sure that you're able to make those the right deciphering the question and using the information that you know. The reality is you'll never probably have to draw a ray diagram on the test, but as part of your studying, you want to master what the ray diagrams are in fact representing. That is the kind of the key in all of this, is that yes, you probably never have to actually draw the ray diagram out, but understanding what the ray diagram is really, really the key to understanding how all of these pieces interact with each other. The formula that you'll use quite extensively is that optician's formula, the 1 over F equals 1 over O plus 1 over I. That formula you're going to see quite a bit. And so, really use this and practice with this. For those of you that are taking the test this Friday or this Saturday, or even, the 24th, I think there's another test on Thursday next week. Best of luck, because I know test day is close. I know a lot of you are taking the test a little bit later on. Best of luck to everybody, of course. It was a pleasure to be here. Hopefully you had some fun. Hopefully you've learned something. And, it's been a joy for us here. I'm going to stick around to answer any questions that you might have that we can help with. But really recognize this is the tip of the iceberg, right? This is part of a lot of things that we do in our programs. And I didn't say this at the beginning, but I'm a very lucky person. I get to do lots of things here at Kaplan. Been at Kaplan for a long time, and I teach on the MCAT channel. I get to work with folks like Gina and Hannah and Henry and Mackenzie and Paul who are all awesome. And I'm also the director of our pre-health program, so I actually oversee all the stuff that we do for our MCAT courses and all that stuff. So, if you got questions, let me know what they are. more than happy to help you kind of figure out what the right thing is for you to do. So you're all very, very welcome. I'm going to hand it back over to Allie. If you're here tomorrow night, I'll see you from Molgen, Molecular Genetics. Always a good time. See y'all soon.
Hi, how did it go? It went good? You loved it? Didn't I tell you you were going to? Like, I am, even now, I still am surprised sometimes at how much more direct we can be in putting science to the test. When I see the new graphics that we're coming out with and the methods that we're explaining, I'm like, guys, how did you do that? I thought we couldn't make it any more simpler, but we did. And I love it. Good. I'm glad to hear it. So we are going to talk about, memory. Has anybody, let's do our 0 through 10 again. Have y'all been studying learning and memory? How much? 0 through 10. How much memory studying have we been doing? I'm glad to hear it, Harley. That's exactly why we do what we do. We're going to go ahead and open up that email poll again. So make sure that you put in your email so that you can receive our post-class handouts and pre-info, like stuff to get your brain working on the next topic, which is Molgen. Ooh, Telassi's like an expert. That's awesome. Jamie just a little bit. David's at a 7. Bren's like, nah, I haven't really touched that too much. 2 for Annette. Well, we're going to talk about it because memory plays such a big part in preparing for a test, right? You are preparing to apply what you have memorized in the past, right? So we're talking about both memory and retrieval. I'm going to give you a crash course. I'm also going to send these notes afterwards of what we talk about. But we're going to talk mainly about memory. And since I've seen a lot of things over 5 for this topic, I'm going to let you guys lead the way just a little bit. We will let y'all be in charge of this lesson. All right, let's talk about storage. But before we talk about storage, let's talk about the 3 pieces of memory. You guys tell me, right? Memory, we're accumulating, we're retaining for later use. What does it consist of? 3 processes. One of them is storage, so I know y'all got that one. What are the 3 processes? What are they? I know y'all know storage. Listen, if y'all missed that one, Yes, I see those emails coming in. Good. Keep those emails coming in. Very good, David. Very good, Giselle. Yes, encoding and retrieving. Good, retrieval. Yes, 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 yes. Storage, encoding, retrieval. Very good. But not necessarily in that order, right? So I think I'll put it the way Giselle put it. We're going to go encoding, storage, retrieval. We're going to talk specifically about storage today because I am the study planning person, right? So storage is obviously very, very, very important to me because you got to store your information or you can't have it later. And you guys are preparing now for a test that is later. So we got to make sure that our storage is on point. So let's talk about the primary factors of storage. Capacity and duration. How would you put that in your own words? Like in your own words, what is capacity or what is duration? Pick one, either one. Define it for us in your own words because these are not super complex topics, right? Capacity, duration. In terms of retention. Good. Capacity, how much? How much are we retaining? Duration, how long? How long? Very good, Rasik. I love it. How much and how long? How much and how long? We're always thinking about how much and how long. Yes, very good. Very good, Mary. Very good, Annette. You guys got this. All right, let's talk about the types of memory. Starting with sensory. Sensory memory. How would you guys define sensory memory? There's a whole lot of sensory stuff going on for you right now. Your sensory memory is firing off all the time. it's like, what's right in front of you? It's all of the things. It's all of the things that you are seeing and hearing and feeling, what you're smelling, whatever is happening around you at any given moment. That is your sensory. And yes, Chadden says you're right. It is the shortest of all the memories. But why? How about that? Why is it the shortest? Why does your brain have to like just send it away so quick? Very good, Lydia. Very good. Yes, Troy. Very good. Rapidly changing because everything around you is changing all the time too. Why is it so important that your brain just like get rid of it? It's so fast. It is the shortest. We hold it like for such a short amount of time. Sometimes it seems like we don't hold any of it at all. It's that overload. There are so many things happening around us at any given time. Your brain would like explode if you tried to hold it all. And so your brain is very good at determining, oh, what do I need to hold? And what do I need to get rid of? And what's important? Yes, Talassi, very good. What's important, not only to protect itself, but also to help you, right? Because there are other things that you want to focus on. If your brain was so busy trying to memorize every detail of every room you were in and every color that you passed and every smell that you smelled for long periods of time, you would run out of room potentially. We haven't discovered the limit of the human brain, but I think it would be a total overload. Yeah, it's too much. It's too much, Jen says. So our capacity here is really small, and your duration is less than 1 second. It's less than 1 second. So it's super, super, super small. An example of your sensory information, we've talked about a lot of them, but you can also think about, I don't know if you've ever played this game, but where they'll put up a group of letters and then they'll get rid of it real quick, and then they'll ask you like, okay, well, what letters were up there? Because you saw it, right? You should be able to remember it. But unless you've attached some kind of importance to something, you're not going to remember it. Maybe you can vaguely make out a shape of one of the letters or two letters in there at the same time. Let's talk about short-term memory. Short-term memory. How long do you think you can hold on to your short-term memory? Let's look at that duration there. What do you guys predict as the duration of short-term memory? You know, your capacity short-term is not very much. You know what, Jamie? I'm going to put it like between Bryn and Jamie. Oh, getting fancy. Getting fancy. Most of your short-term memory, you're going to hold for less than 1 minute, unless you work on it. So you can work on it, right? But then you're in the process, you're moving it to long-term memory. Long-term memory is that memory that you can hold. You don't necessarily hold it forever. You could hold it up to forever if you apply enough importance to it and enough repetition. Then you can have it for longer. But short-term memory, it's not necessarily that long. It could be less than a minute that you hold it. Your capacity is, about 7 things, but a list of 7 things. 7 is such a good number. Does anybody know what used to be 7 digits? It's such a weird question. That was a weird way to hold it, to phrase it. I know you guys are probably too young anyway to know the answers to this. Phone numbers. So phone numbers used to be 7 digits. This is before they started adding area codes. And you could remember all the phone numbers that you needed to know, right? Because you used them a lot. But yes, very good, Celeste. Very good, Whitney. You know they did that on purpose. Someone was like, you know what? People are really good at holding on to 7 digits. And so let's make our phone numbers 7 digits, right? So that you can hear it and you can hold on to it. And then you can do things to start to grow the duration, start to move to long term. What do you guys do with your list of things? Like if you're given a phone number and you need to memorize it, I don't know if anybody still needs to memorize phone numbers. You all have your smartphones right there, right? Or your grocery list. Imagine you don't have a pen and paper, no pen and paper. And so you have to rely on your memory and you're getting out of your car, you're going into the grocery store. What are you going to do to help yourself? Jamie, do you put it in a song? I think that's great. I think that's great. Yeah, so we're usually going to repeat it. So we're going to repeat it somehow, repeat it in a song from Jamie, or just say it out loud. So I'll tell myself, I'll be like, eggs, toilet paper, milk. Eggs, toilet paper, milk. And then I go and I'll try and remember. And invariably, I will come into contact with so many other things and think about so many other things. They're probably not going to remember my entire grocery list, unfortunately. But we try, and one of the ways that we can work on that is repetition. This is showing your brain that you're attaching more importance with it. Guys, repeat, 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 Meg. And you repeat it, and then you get to remember it for another short term. You read it, and you remember it for another short term. That's true, Henry. That's true, Henry. Let's talk about working memory. How long for your working memory? What is working memory? In your own mind, in your own words, in your own words. Working memory. You know, it's just like, I mean, that's how it works. So you can repeat it, right? But I will tell you that you're not going to change it. You can either decide that something is important enough that you're going to do the things that you need to do to change where you're storing it. Very good, Bryn. Yeah, I like that definition. So what we're using and retaining at the same time. So this is the active. We're holding it, and it's a lot of things. It's moving pieces that we're using while we're also retaining. Duration here also very short, less than a minute. A really good example is math. Can I give you like a math question? I want you to do this math question in your head because we're talking about storage and retention. So let's do let's see. Let's do 21 times 17. See if you can do it in your head. It's not a quiz, so if you get it wrong, it's okay. But let's do 21 times 17 in our head. Let me know when you get the answer. Good, very good. Close, Jamie, close, so close. It was 357. But let's talk about what you just experienced, right? When you are doing this math problem, this is not super hard math. Like if you were doing it on paper, you'd have no problem, right? But did you guys have to at any point like repeat to yourself, okay, I got 7, or like I'm gonna carry my 1, or I'm gonna add these together, and you have to kind of like repeat what you're doing? Because your working memory is when you're having to take all of these pieces of information. Like you have to keep it. You have to remember the numbers that you were given, right? So you have to remember the original numbers that I gave you, right? I do too, Brittany. It's actually pretty hard for me. You got to remember the original numbers that I gave you. You have to remember the operation that you've been given, which in this case is multiplication. You have to remember any numbers that you come up with along the way. So those numbers that you had to add together, you have to remember what those are. And then you have to remember like you've added them from right to left or whatever. And then eventually you get to that answer. So holding on to all of those pieces at the same time without letting go of them, that is your working memory, right? You're also using your working memory on test day. Right? On test day, you'll be using your working memory a good bit. And so let's talk about like math on test day. Are you guys going to try to do your math in your head on test day? Sometimes students say to me, yeah, I'll do it in my head. It's not so hard. It's faster. It's just faster to do it in my head. Right? Given what we've just learned about working memory and the fairly simple math problem that we've been given, do you think it's a great idea to like do it in your head? No, right? So you can do it pretty quickly on paper too. Plus you want to see because working memory, there's the pieces. So you could easily just drop one off and not even realize, or just make a simple error, or you could just end up spending more time because you think it through and then you're like, oh, let me check my working, and you have to think it through again. Better to do it on paper. And also with your short-term memory, let's talk about short-term memory. So when you are doing your MCAT passages, you're really working on your short-term memory in that time, right? So you're trying to take what you've just read and apply it to questions. You should go back and research and check your work and everything. But sometimes even knowing what each section was about is a little bit difficult, knowing where everything was, and trying to hold it while you're doing other things like reading the new questions, reading the answer choices, becomes difficult. You change the type of memory that you're trying to employ, and you make your task different. So that's why, what do you guys think I would tell you to do as you're reading your passage to free up brain space and to ensure that you do not fall prey to your own brain's capacity and duration for short-term memory? What could you do very simply as you're reading those passages? Yeah, just take some notes, Mary. Just some really simple notes. I love it. Yeah. Let the little notes, let your outline that you're making for yourself serve as your short-term memory so that you don't have to hold that. You can free up your brain. Also, just the task of writing it is telling your brain that it's more important. So you're likely to hold on to it at least a little bit longer. But also, it frees your mind so that when you're reading questions and you're trying to understand those tricks and those traps, the logic, the reasoning that they put into the question, and you're trying not to fall prey to that, you don't also have to be holding on to everything that you read in the passage or even where everything is in the passage because you have left yourself notes. And now we'll take the place of that short-term memory for you. So sometimes students really don't want to outline. They're like, well, what do I have to outline? You know, I understand this stuff. Well, it's not about understanding. It's about increasing your duration. It's about helping your retention. And it's about sometimes just serving the function, right? Taking notes as you read a passage. Those notes now serve the function of your short-term memory. So you can stop doing that. Your brain is now free to work on something else. Your brain doesn't have to look at the question and say, okay, well, let me only allot this much over here because I'm trying to hold this still over here. So don't be afraid to outline. Don't be stubborn about it. It's not because we don't think you can understand or whatever. It's because you have to do things to actively help your memory. And also you need to make sure that your brain has as much open space available for getting right answers as possible. And that requires not bogging it down with all this memory work that's also doing. All right, let's talk about long-term memory. What is our capacity? What is the human capacity for long-term memory? How much stuff can you shove in there? How much room do you have? Does anybody have the exact number of things? The human brain can hold 1,272 items exactly. Students, is very good. It is, so far as we know, it is unlimited. So far as we know. I mean, there may be a limit, but nobody's gotten there yet. It is unlimited. And the duration can be extremely long. It could even be up to a lifetime. There could be things that you remember for the whole rest of your life. I don't think anything for your MCAT do you need to remember it that long. But you definitely want to be able to remember what you're studying now on test day. And then you also are going to have to be able to apply it and not do other things with it. But let's talk about long-term memory. How do you get things into your long-term memory? How do you plan to take what you learned tonight and Teacher Petros's lesson and get it into your long-term memory so that then you can have it when you need it on test day? How is that going to happen for you? What's your plan? What's the plan, Stan? Okay. Yeah, practice problems will help, Alexandra. Absolutely. That spaced repetition, absolutely. Reviewing your notes again, for sure. For sure. Write it down 3 times. Yeah, that actually really helps me too. I really like that one. Yeah, so this is something that you need to employ all the time now. So if you are just reading your way through these books, and I got a lot of emails like this, like, hey, I'm reading my way through book after book of the Kaplan 7 series. Listen, the Kaplan 7 series books are great, but if all you do is read one time, once through all of them, and that's it, your memory is not going to hold on to all of that because your brain doesn't work that way. It's not because something is wrong with you. It's not because something is wrong with the book. It's because memory doesn't work that way. If you want to put something into long-term memory, it takes multiple times of touching it. And also the way you vary how you touch it is going to change how much you retain and for how long as well. So one thing you read your way through a chapter, right? Then talk about it in class. So you've read about memory and now here you are talking about it. You're going to remember this stuff even more. You can go do practice questions and then another practice question and then another one. And then we'll go back and maybe we'll review our notes a couple of days later. We'll do that and repeat, right? So you have to do this all the time. So you cannot be the student who is so smart that you know all this stuff because you just sat here and told me that you pretty much know everything that you need to know about memory for the MCAT, or for storage, for storage of memory for the MCAT. You guys had a lot of answers, you knew a lot about it, but if you're not applying this in your MCAT prep, you're not going to be able to memorize blood type antigens and be able to recall them on test day. You're not going to be able to do that. So you have to take what you already know and also apply it to your study prep, right? So as you're studying your learning and memory, think about how you can also employ that knowledge to increase your point gains in between now and test day. So I'm going to send out notes. I'm going to send out notes over memory. I'm going to send my notes both for storage, encoding, and retrieval as well. So you guys can have those on hand afterwards. But I want you to really think about that because some of your study plans are not based on anything other than maybe kind of panic. Like, well, I don't know what to do, so I guess I'll just do this. But you are very smart. You understand how memory works. You understand how retrieval works. I bet if I even asked you what type of retrieval you needed for test day, given that it's a multiple choice test, I bet at least a few of you would know because you've been studying this for a while. So make sure that you take that information that you know about learning and memory and apply it now in your prep. Don't make study plans that don't incorporate the way your brain works. Make sure you have the practice items. Make sure that you are repeating things. Make sure that you are employing all the things that you know in order to help yourself. Like diagnose yourself. Diagnose yourself like a doctor and then apply. So that's what I have for today's lesson on storage and retention of information, how to use that on your MCAT prep. I hope you found it helpful. I'm going to send these notes. Make sure that your email is in the box. Please put your email in a little box. Let's talk about questions. We didn't have time for questions yesterday. I would love your prep questions, your MCAT questions. Go ahead and let me know. Hit me with them because we have some extra time tonight. What are you guys thinking about? What are you guys thinking about? You're welcome, Elise. You're welcome. No questions tonight? I know you guys have questions because I already have like 5 emails since we started the lesson. Of course, you don't have to ask them publicly if you don't want to, but I want you to make sure that if you do have stuff that you want to answer right now. Day before test tips, absolutely. You're so welcome, Whitney. Thank you so much. You have fabulous taste. You're welcome, Annette. Troy, I love that question. The day before test tips. I would tell you, I suffer a little bit from anxiety. I don't know if anybody feels me on this. I really could not sit still. So like the day before, I'm not going to be able to just rest. If you're the type of person who can just rest on the day before, I love it. Do it. Rest away. Go to the spa. Hang out with your friends because you have been studying so much. And there's nothing that you're going to learn, and just even thinking about the way the brain works, there's nothing magic about that last day that's going to make the difference, right? So if you can rest, I would rest. I can't, because I would be spending the whole day just worried about the fact that I'm not doing something test related, and that anxiety would actually hurt me a lot more, and I would not be restful at all. So that's something about me. So for me, instead, if you're that type of person, you know you are. If you're the type of person who knows you can rest, go be that person. I envy you. And if you're the type of person who knows you can't, then what I suggest is just doing really easy stuff, like reviewing some of your favorite topics, right? Nothing difficult, no super hard questions, definitely no tests, nothing that is going to spook you or make you feel like, oh my God, I don't know that, I don't remember. Just like going back through things that are super simple or that you like or find interesting, just so that you know that you're keeping your brain moving and you feel comfortable. Don't overdo it, just a little bit to make sure that you don't get that anxiety. But again, if you can rest, just go rest. I totally envy you. Carly, how can you watch more videos? You're signed up for more this week, but you really love them and you want to watch as many as you can. Oh, Carly, that's great. So I will tell you guys, and I'll put it on the screen too, captest.com /events. You can always see all of our upcoming free lessons throughout the week. Now, a lot of them have the same content. So once you've been to it once, it's not going to do you a super good to go again, but not all of them. So make sure that you're coming to that. We have free practice tests. We have random free MCAT channel lessons. Like this week, we do it like every day, but we do like one a week otherwise. Our boot camp as well, so you can always do that. Outside of that, you know, enrolling with Kaplan is always a great idea, because all of our lessons, from like your classroom session to your MCAT channel session, they're all in archive as well. So you can watch them all in the archive, or you can go to them live, which is amazing. Or it depends on what you are studying. So another thing that we have, and this is actually really good for short-term prep. So if you are kind of up against the time limit, let me see if I can get the link here. If you're kind of up against the time limit, we have our science review video pack. So it depends really on what it is that you're trying to get videos on. If you're trying to do strategy, I would definitely advise you to definitely sign up for our course and get that strategy help. But if it's still about content review, our science review video pack is great. Let me get the link here. I'll put the link in the chat. So it's got over 100 active, like interactive videos on our highest yield topics, which I know that you guys have been interested in knowing more about that. So let me put that into the chat. I'll put that there. So you can always do that as well. So that's 3 different options. You can sign up for Kaplan. You can get you could buy some videos on their own, or you can come to our free events channel. But yeah, I think they're great too. And you know what I've found too, and you guys who have books can tell me if this is true for you, because I know a lot of you have the books, as you said before earlier in the lesson. I hear very often that the lessons make the books like come alive, to where all of a sudden, like, things that you had to read a couple times, it's like, now I get it. I think it's a combination of like just hearing it in a different way, focusing on that learning method, and then also but the teacher is going to say it slightly differently, and it's going to be adapted to you. The more active you are, we're going to change the way we say things. If the question is getting missed a lot, we're going to tweak the way we say it. If you ask a question and we see where your confusion is, we can tailor that explanation to you. So I think I totally get it. Like I have never been the type of person who can learn just from reading. I have to have a conversation. If I can hear you talking and ask you a question, I can learn it like that. If I have to read, who knows how long it would take me. I have no idea. Where is the place to test the content? So if you're talking about like science content, Mary, you know, our 7 series books are great, and we have a quiz at the end of each chapter to test your understanding. In the Kaplan course, we do use a science content quiz just to see, not just a full-length diagnostic, but also we just test the student just on science content. That's all the science is tested on MCAT to see where you're at. We also use an adaptive Q bank. And that link that I put up before also has a link for our adaptive Q bank. It's actually one of my favorite resources. It's only 99 bucks, but it's got over 2,000 MCAT practice questions in there. But the thing that I really like about it is that you can use that to see what your content deficiencies are, and it adapts to you. Like, so based on your performance, if you're stronger, if you're weaker, it will adjust and say, okay, she's a little stronger, let me give her higher difficulty questions on this topic. Oh, she's a little weaker, let me bring it down a little bit. And then the explanations are there as well. So you can let that lead your content review instead of, you know, just studying all content and then hoping you're ready for the MCAT. Study the content that you need at the level that you need it. So those are some things that some places that I really like for testing content. Whitney, with the live class versus the plus, it says you get the biochem and behavioral sciences. Does that mean that? No. Okay, great question, Whitney. So Whitney is considering the plus courses versus the regular live online. And the live online plus courses and all of our plus courses come with 2 additional foundations courses, foundations of behavioral science and foundations of biochemistry. And she's saying, wait, does that mean that you don't have that or material for that in the regular course? That's not what that means. We cover every single thing that's on the MCAT. However, as you guys may know, a few years ago, the MCAT changed. About 3 years ago, the MCAT changed and started including biochem and behavioral sciences where they didn't before. And so some students came in unprepared, and as some had graduated, or even some of you may have graduated before that was a requirement of the MCAT and had not taken that class. So our foundational lessons are for students who really struggle in those areas or for students who never took those. We also have people who are preparing for the MCAT who have yet to even take biochem or are currently in biochem. So that is for students, especially for students where that is a real struggle area or where they've never taken it, because it takes it all the way back to basics. So we start at ground zero as if you have never heard it. So it's not a content review, and it's not a chapter on content review, and it's not a lesson on content review. It's content teaching from the ground up as if you have never heard it. So you can figure out if that's something that you need or you don't need. But it's a great thing to think about. And also, are you guys signed up for AMSA, the American Medical Students Association? Because if not, you absolutely should. I'll put that link in chat, amsa.org. A really cool thing that AMSA does is they actually will give you one of those courses for free, one of those foundational courses. They're partnered with us. There is some amount that you have to pay to sign up for AMSA. I don't know how much it is. Maybe, Henry, can you look that up for us? But it's well worth it because you get 10% off of a Kaplan course. So that would be like, I don't know how much courses are right now, but it'd be like almost $300 right there if you sign up for a Kaplan course. Plus, you would get that foundations for free. So you can try it out. So you wouldn't get both of them, but you could get one of them totally for free. So that's like a really cool resource. You're so welcome, Whitney. That's like a really cool resource to sign up for. And then once you do it, not only would you get that, but then you also get that huge discount on Kaplan. And it's also our only stackable discount for Kaplan. So when you see Kaplan goes on sale and it's like, oh, $300 off Kaplan, if you're signed up for AMSA, your 10% is going to add. So it's going to be a lot more for you. It'd be like almost like $500 off Kaplan. So it's just a great thing to sign up for because of that free course, and then because when you grow that to cover the other Kaplan resources you might need, it's going to save you a lot of money. Byron, you plan to test in January 2019. How long do the self-study plans last? Oh, that's a great question. So they're going to start at 6 months, Byron. But one really cool thing about Kaplan that people don't know is that, or don't always know, is that Kaplan does allow you to repeat your course for a new and different test date entirely for free. Because we know that people end up having to change classes, class schedules, or life schedules, or plans, or whatever. And we don't want you to be like, oh, well, too bad. You said you'd be ready by June and you're not. Oh, well, we would never do that to you. So you could definitely stretch your prep out. What you need to do is, I think it's here actually. I'm not sure where my face is at right now. Where it says discover your best prep plan, Kaplan Teacher Consult, that you can book me. Or by calling 1-800-CAP-TEST anytime before 9 p.m. on a weekday, anytime before 5:45 on a weekend. You can tell them your plan, Byron, and they will tell you how to extend that and make that happen for you. But yeah, they could definitely figure that out for you. And then that goes for all of you. If you invest in any kind of Kaplan course, if you in any live Kaplan course, any self-paced Kaplan course, and you need to change your test date and want to keep your resources, that is the thing that we build into every single purchase, because we want to make sure that you just don't end up not making your end mark. I mean, we're only successful if you're successful. So we try to make that pretty easy. I will say too, Byron, when you're looking at self-paced, yeah, I like self-paced. Go ahead. I take it. But do make that call, because then they can, as they enroll you, they can put notes in there and also talk to you about how to spread it out and also make that plan with you so that everyone can be really clear. But yeah, they can definitely take care of that. David, how much time should be spent on remembering equations? Now, you know what? Unfortunately, there are some equations that you're going to need for the MCAT. That is an absolute fact. It's probably less than you're expecting, but you are going to have to spend time on it. We go over this. What you can do too is you can email me at consultedteacher.com, or I sent out a little something on equations. But yeah, there are some that you're going to need, and we can discuss which ones those are so that you can figure out how much time it will take you. But like, nothing should be weighted towards memorizing. Everything should be weighted towards application. So it wouldn't be like a huge amount of time. But if you're hoping that I'm going to tell you that we don't need to memorize any equations, that would be a lie, unfortunately. So we're going to have to. But go ahead and email me and we can discuss in more detail. Whitney, if I already have the Kaplan 7 series books, is there a program from Kaplan that I can purchase that does not include the books, making the price cheaper? Whitney, I will tell you that books come like free for students who are Kaplan students, so it wouldn't decrease. So it wouldn't make a difference to your course. Although I would still call 1-800-CAP-TEST when you order instead of ordering online, and just explain the situation to them and just ask them. Also, you know what I can do just as a teacher? I have, and you know what? I don't know why I didn't tell you guys this before. Maybe because I don't really, I don't deal with the purchasing or selling of stuff very often, but I do have a code. So it's not like specifically for your books, Whitney, or for anyone, but if you guys do need help, I can give you a special discount code that will take $200 off, which would make up for those books off of any live or self-paced course or tutoring. So I just put that in there too, so you can have that. But I always think that you should call to enroll rather than doing it online, because there's always so many extra things that you might not know about that you want to find out. Like right now we're having, we have a bunch of help for admissions. So if you've ever had questions or needed help with your admissions, like the packet rather than just the MCAT, we have self-paced admissions help, and we're giving that free right now to anyone who enrolls with our MCAT course. You're so welcome, Whitney. So enrolling now is a great time, and also just enrolling over the phone is a great idea, because they can make payment plans, they can make payment arrangements, they can apply discounts, they can help you understand which course is right for you or the link. Whenever you call 1-800-CAP-TEST too, you always talk to a teacher. So it's not just like someone who's been trained on the phone. It's like an actual teacher. So you can really discuss your plans and like what's right for you. And you don't have to try and figure that all out yourself, because like I just didn't even know the price of our course off the top of our head. So I don't know how you would be able to navigate all that stuff. You can, Carol. So you can purchase the QBank all by itself. Absolutely. It's $99. I will say that the QBank is largely discrete questions. Everything comes with answer, explanation. It's adaptive to you and your ability. It tracks you. You can see all of your previous work too, check your stuff, and it's going to make it easier and harder as you're ready for that, which I think is really, really cool. But it's a lot more discrete questions than it is passage. So I really like to combine that. And like, if you're not going to get a course, all of this stuff comes with the course. And it's more cost effective to get a course altogether. But if you are definitely not going to do that, and that's not in your time frame, then I would, in addition to that QBank, get the passage-based question pack, because that's all passage-based questions. That way you can really do them both, and both of them track your performance. Both of them you can go back and see your previous work. So I think that combo is really great. But yeah, you can definitely get the QBank all by itself, which I think is really cool, and it's adaptive. I think that's really the difference between MCAT prep and just watching a bunch of random videos out there in the world or reading a bunch of random chapters out there. For MCAT prep, at least here at Kaplan, and maybe this is one of the reasons that we are the world leader in MCAT prep, is that it's all adaptive for us. Like, we have custom homework assignments based on performance for students. Our QBank adapts and changes difficulty level based on your strengths and areas of opportunity. We're always letting you go back and see your work, go through those explanations, always tracking things, and we're trying to personalize to you, because no other student in this class right now has your same strengths and your same areas of opportunity exactly. None of them. So none of you should be studying the exact same stuff the exact same way, the exact same difficulty level. And probably, I'm not sure, but probably almost everybody is going to do better under the guidance of someone who knows what they're doing in terms of figuring out what to study when and at what difficulty level than you're going to do on your own. One, because sometimes we overestimate our abilities, sometimes we underestimate our abilities, sometimes we just get overwhelmed and we'll just grab whatever's nearby and say, at least it's MCAT, I hope it's helping. But I really love those adaptive materials. So yes, QBank is available. I would also add the passage-based question pack if you're going to do that, but it's cheaper just to get the whole course once you add in all of the features together. Your access to the online content that came with 7-book bundle expired last year. Is there a way I can renew it? I'm like, Taba, I think no, because the books have changed. But it's worth calling back. So I would just call 1-800-CAP-TEST, just call them, let them know, and find out, because our courses can be extended and different things can happen. So I would just call and just find out what that options are, if there are options there. But we have new books too. And the MCAT is always changing, not necessarily the topics that they test, but how much they test at what difficulty level. And we're always tracking that. We also have an entire team of learning scientists that work for us. We have our own learning science team, which I think is so cool. And so we're always changing the way that we teach and the way that we present things to help you to retain things for longer and help you to understand better and help you to get points faster. So we're always upping our game too. So I might advise that you get a newer set of books, but also just call and see what options there are, because there's always something. There's always something that can be done. All right, good. We went over time. I feel like we got to all the questions because I don't see any more coming in. So, I always like to end on the same note. You're so welcome, Mutaba. Thank you so much for coming. I am not at all overestimating or exaggerating when I say that teaching, and especially test prep, has really, really been the highlight of my career so far. And I don't get to do that unless you allow me to. And I remember how scary it is. Like, who has the right material? And I only have so much time, and I feel so scared. I feel so overwhelmed. And who can I talk to? And what should I do with my time? And I made the decision to come to Kaplan, but I know that that was a hard decision for me because I had all those feelings. So when you come to my classroom, in a way, it makes me feel like just very honored that you have chosen us and that you have trusted us to be a part of your prep journey, because that is a big deal and it really means a lot to me. So thank you so much for allowing us to be a part of this really important part of your life, for allowing us to do what we love to do, and for helping us to make this magical free week of MCAT prep, which we love to do every time. I will be sending out those emails, so make sure that your email is in the poll, because if your email is not in the poll, I can't get you the email. Also, my direct email is there, consultantteacher@kaplan.com, so you can reach out to me all week long for help and advice if you need it. And that's us. That's it for tonight, but thank you so much. I look forward to seeing you all tomorrow for molecular genetics, and we will see you there. Bye-bye.